In this video, we will see how Gaussian elimination tells us that a system of equations may have infinitely many solutions. But before we start the calculation, let's see how do you feel the meaning of infinity solution first. The question can be as simple as, for example, like x plus 2y equal to 5. Can you tell me the answers? Most of you may think of, it's 5, 0 is one of the answers. Or some of you will think of 1 plus 4, that means 1, 2 is also a solution. Or some other of you will be thinking of 4 plus, not 4, maybe like 3 and 1 is also a solution. If you continue to list out, even including fractions and also decimal numbers, you will find that this question has infinitely many solutions. So it builds up our foundation, infinitely many solutions. Let's write here. So it builds up our very fundamental idea of how we see the following system of equations has infinitely many solutions. So let's see what's going on. Okay, in order to start our Gaussian elimination, of course, we take out all the coefficients and write it as a matrix form, or it should be called augmented matrix. We have 2, 3, 8, 4 for the second row, 3, 2, 17, and 1. So now please stop the video for 1 or 2 minutes time. Then next you will check the answer against my work. Alright, so please check the answer. Generally speaking, it should be alright for you to find to do the row operations. First of all, we want to cancel the 2 and 3 in row 2 and row 3. So by the following operations, which are put in blue. After that, you will see that there is still -1 and -4, which is not convenient for me to do the calculation. So that's why you see I divided by -1 and -4 respectively to obtain a 1 in row 2 and row 3. Afterward, of course, we are going to cancel the last one in the third row. So that's why it comes to the last operation. The very special thing you will observe in the question will be, wow, this time we have wholly zeros in the last row. What does that mean on the question? If you rewrite it to a system of equations, you will see that you have x plus 2y plus 3z is equal to 3. The second row tells you that x minus 2y, it should be y minus 2z equal to 2. Can you see that this is the case that we discussed in the beginning, in which there are infinitely many solutions? Next, we come to look at how we can present our answer as infinitely many solution. So because we can't list out all the answers of it, right? So the way to do will be, because the last equation, y minus 2z equal to 2, carries many solutions. So that's why we will be making use of an unknown or parameter to serve the purpose. So what does that mean? That means now we will say we let ez to be a t. So t can be any number. So we write as t belongs to real number. So that means t itself can be any real number. According to the same equation, you have y minus 2 plus 2t. So this is the new look of y, which is the solution. Next, we put it back to the last equation. We have x is x plus 2 times y. That means 2 plus 2t. 3 is 3 times t equal to 3. So as a result, x now carries a kind of solution which is equal to -1 minus 7t. So that's why we will say x, y, z. Now we have a solution which is called -1 minus 7t, 2 plus 2t, and t will be the solution. You find it very weird to you, right? But you remember that t itself can be any number. So now, according to these formulas for x, y, z, we can generate as many answers as possible. So this is the end. But how we can understand it depends on how you treat or how you consider t. For example, if t is 0, then you have the answers to be -1, 2, and 0. This is one answer. For example, t is 1, you have another answer would be -1 minus 7, that means -8, 2 and 2, which is a 4, it is a 1. Then you generate another one. For example, t would be -1, let's say. Then now you have 6, 0, and -1. So this is what we call the purpose or the significance of t. Because t itself can be any real number, So once you substitute t to be a certain number, you generate one answer for x, y, z. You substitute another t, you have another answer. So it is a way how we can present infinitely many solutions in a system of equation.